Okay, so this one, this portion for class 9, chapter 3, atoms and molecules. The portion we're going to discuss right now is very important, okay? We're going to use this one to solve all the numericals. So this question number 40, 41, and 42 on your tuition note, as you can see, right? So let us try to understand them. Now let us start with this gram atomic mass of carbon. Let us say the carbon symbol C here. Now we know that at the back, if there is no number, means there is only one atom. So that's why we call it the gram atomic mass. If you compare that with this O2, for example, then we see here two oxygen atoms here, connected by a double bond, of course. But the point here is not the bond here. Two atoms means molecule, more than one atom. But here only one atom, so we call it atomic mass. When we have more than one atom, whether same type or like this or different type also, it will be called a molecule. Okay, like water, there is two types of atom. That's a molecule. So more than one atom is molecule, one atom is atom. Okay, so here, when we have only one atom, we call it as gram atomic mass. So gram atomic mass of this carbon is, we know in page 37 of the textbook. So the back one means only one number we write there, and each carbon atom is 12 U, right? Unified mass. But since it's gram atomic mass, we change that U to G. So we know gram atomic mass of carbon is 12 grams. Okay, so what we're trying to do is this one. Now take a balance. Let us say that we have a very sharp, sensitive, accurate balance, and we weigh exactly 12 grams of carbon on this weighing pen. Na pala idu alu khan ujun korina the type, but this is a special balance, let us say, that can measure accurately. So exactly 12 grams of carbon you take out. So here, that one, and gram atomic mass, okay, mass of carbon. Just now we found it out to be, that is 12 grams, right? So this one, if you count, let us say this is the picture of the thing that you have taken. So these are carbon atoms, exactly 12 grams here. So we took this one, and then scientists found out this one, that when they took 12 grams, the gram atomic mass of carbon, and weighed it, and start counting the number of carbon atoms in 12 grams here, they found out that it contained exactly 6.022 into 10 to the power 23 atoms. What type of atoms? Carbon atoms. Which means if you write the real number, it will be, let us try, 10 to the power 23 means there are 23 zeros. So when you multiply by zeros, we know the decimal move to the right. So 23 places. So let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Huge number. In fact, you can even say difficult to count. It will take a long time to count. That just 12 grams, the gram atomic mass of carbon, we measure it, and then take and start. Suppose we could actually count it. Then we will count exactly this much atoms. Okay. Now, let us take a molecule, for example. So, example B. A we have taken. Now B. Let us take the gram molecular. This time we're taking a molecular mass of a very common substance, water, let us say. So we know this is a molecule because you see there is more than one atom. See here, two hydrogen atom and one oxygen atom means there are three atoms in one molecule. So anything more than one atom is generally called molecule. So when we have more than one atom, we have to write gram molecular mass. When only one atom, no number at the back like this, we call it atomic mass. Okay, so here we know this. There at the back of H is 2, means there are two hydrogen atoms. So 2 into 1 plus here 1 at the back of oxygen. So we can write it here for lack of space. You can just write it below here. So 2 into 1 plus at the back of O, no number means only one oxygen atom, into 16. If you check page 37 of your text, then you'll find out hydrogen mass is 1 and oxygen is 1 atom is 16. So we put G here, grams, because we're talking about gram molecular mass. So we get here 2 ones are 2, 1 into 16, 16. So 16 plus 2. So 18 grams is the gram molecular mass of water. So you weigh like that exactly on the balance. Again, 18 grams of oxygen. So you'll find out here 18 grams, which is the gram molecular mass of water. Again, just like carbon, it contains this time same number of particles here, 6.022 into 10 to the power 23, but this times it will be called molecules. So this is interesting because you're getting the same number. Every time you take the gram atomic mass of an atom or the gram molecular mass of a molecule and count the number of atoms or molecules, you get the same number of atoms or molecules or particles. So this is interesting. So this amount here, 12 gram, which contains this 6.022 into 10 to the power 23 atoms, and this 18 grams of water, gram molecular mass, which contains the same number, 6.022, you see, 10 to the power 23 molecules. This amount here, 12 gram of carbon or 18 gram of water, is called the 1 mole of carbon, or we call this one as 1 mole of water. Okay, so 18 gram of water makes 1 mole. 1 mole, in other words, is the amount of substance here, 18 gram of water, which contains exactly this much particles. So that is the definition for 1 mole. Okay, so here we can read now. That quantity of a substance that contains 6.022 into 10 to the power 23 atoms or molecules, if it's molecule, or particles even, is called mole or 1 mole. So that is the definition of 1 mole. So the concept of 1 mole, gram molecular mass or atomic mass, and that number here are very important. Now the number of which is here is 6.022 into 10 to the power 23 atoms or molecules or particles, that is always found in exactly 1 mole of any substance you take. You'll always find the same number of particles inside that 1 mole. It's called the Avogadro number, okay, in honor of the scientist who discovered this mole concept for us. Okay, so that is the one. So now we can answer 41 on your tuition note. You can pause the video and write it if you want. 1 mole of an atom, any atom, whether carbon atom or oxygen atom or sodium atom, is always equal to the gram atomic mass. Yes, gram atomic mass always makes 1 mole because the gram atomic mass contains this many exactly Avogadro number of atoms or molecules. So you can think there, yes, okay. One or same concept, 1 mole of a molecule is equal to its gram molecular mass. Yes, if it's molecule, 1 mole will be equal to gram molecular mass. If it's atom, 1 mole will be exactly equal to its gram atomic mass. So from here we can today derive a formula that is going to be the basis of 70-80% of the numericals that we're going to do in this chapter. So let us write that formula here. Just now we got it. So just write down 1 mole. Okay, 1 mole, just now we discovered, of any substance is always equal to how much? How much is the amount of 1 mole? It's gram atomic, okay, gram atomic or molecular mass. If it's molecule, molecular. If it's atom, atomic mass. And this will contain the same number of atoms or molecules, 6.022 into 10 to the power 23. There will be that many atoms if it is atom, or the same number of molecules you will be able to count in 1 mole molecule. So this is the formula we have understood, and we need to keep this in our mind in doing your numericals in this chapter. Okay, so that concludes the video for the mole concept. And once you get the mole concept, which is, again I repeat, 1 mole always is equal to the gram atomic mass or gram molecular mass, and gram atomic mass and 1 mole of the substance always contains the same number of particles, 6.022 into 10 to the power 23 atoms, or if it's molecule, that many molecules. So memorize this, understand it first and memorize it, and you'll be able to do almost all the numericals in this chapter. Okay, so that concludes this video.